Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. One of the students asked me to have the centers of triangle, like just summarized. Um, and usually there are too many centers of triangle, but I think you cover in geometry like four of them, the four most famous ones. These four have different properties and different uses. And then if you have an equilateral triangle, so if the triangle had the three equal sides and three equal angles, then all of these four will coincide into one point. Okay, so we will start with the first one. So I made four triangles, save you the time of construction, made a copy of those. So the first one you can see, these are angle bisectors, okay? So the first one is angle bisectors. So we divide into angle into two equal halves, in which case we will get a point here. Let's call it O. This point O would be the center of a circle that we call the incenter, or the center circle, okay? Incenter, meaning it touches, later you will see, you will learn another word for that, but it touches these three sides into just 1 point each, okay? So if we get compass, I don't know if we try to make that touches one of the sides at 1 point, roughly. I mean, it's not drawn to scale, most likely, but you can see here that it touches each side in 1 point. Again, if it was drawn properly, I did that quickly, so it's pretty much accurate, but not that accurate, so to speak. So that circle is called the incenter. That point is the incenter, meaning the circle here touches the triangle from the inside, okay? Just touches each side at a single point. So it doesn't cross and then come back, like just 1 point. Okay, and that's basically it. Now, if you take the perpendicular bisectors, did I do that next or did I do some? No. Okay, so let me find that. Okay, here is the perpendicular bisectors. Here, instead of dividing the angles into two equal parts, we divide the sides, okay? And then we draw perpendicular lines. So this angle is 90 degrees, this angle is 90 degrees, and that angle is 90 degrees. Okay, so we call that the perpendicular bisectors. There is a U, missing U here, sorry. Bisectors. Okay. And that will give me the circumcenter. So this center where they intersect will touch the triangle at the three vertices. And notice that this can be inside if the triangle is acute. It can be here if that was a right angle, or it can be outside when one of the angles is obtuse. So now again, if we enlarge that, make it equal, so let it pass through one of the vertices. I don't know. Oh, again, it's not accurate, but oops, So it passed through two and not all three. Again, as I said, I was trying to do that quickly. Maybe I should have spent more time to do it accurate. But if you plot the perpendicular bisectors more accurately, you will get a point. At that point, if you make the radius, the distance from this point to any one of the three vertices, it should pass through the three vertices of a triangle. Again, this is probably the only one that has a unique name. Like we say, we don't. You see, you have, yeah, we have angle bisectors, or if you say just bisectors, we understand it's angle bisectors. And that's basically, I was in a French school, so we had a name for the perpendicular bisector. So when we say bisectrice, we mean a angle bisector, okay? And this one was called the mediatrice. So like between median, and you see, it's like, we know it when you say mediatrice, we mean, we know that we are drawing a perpendicular line in the middle of each side, and they coincide at a point, and that point is the center of, or the circumcenter, because these three vertices would be at the circumference of that circle. Okay, again, sorry for it, it wasn't drawn to scale. The third one is easy, it's the medians. So these are the medians. So now again, I take the middle of each side, but I don't draw a line perpendicular to it. No, I join it to the opposing vertex. They will intersect at a point. This point is called what? The centroid. So that point, say O, O here is called the centroid. What is the centroid? Centroid, you might have heard it differently as the center of mass, of center, or center of area. And that's basically, if I have some kind of a triangle made of any material, like steel, aluminum, whatever the case is, and you want to hang it such that it stays horizontal, you have to hang it from this point, which is the median or the center of mass. I have an advanced or slightly advanced session on how to find the center of mass of different shapes, but really you are going to learn that later. What's important is that this point divides each median into two parts in the ratio 1 to 2. So if I if I call these, I'm sorry, A, B, C, and then these three middle points, so the middle of AB, for example, is E, the middle of AC is F, and the middle of BC is G. We say that OG over OA equals OF over OB equals OE over OC equals 1 to 2. So if that median length, say, is 9, it will be divided into 3 and 6. And so if that's 6, then this is 2 and 4. Ratio is 1 to 2. Okay? And that's called the centroid for any triangle. Again, as I said, there is a session, I think it's posted in the engineering portion of statics, the course of statics, that shows you how to find the centroid of really any shape, so to speak. And I give a small table to show you how to find the centroid of a rectangle or a triangle or second degree or third degree or nth degree parabola, very easy. Maybe I will simplify it here quickly, but that works if you have a right triangle, only a right triangle. Again, we can prove that this point is the centroid, but it's really beyond the scope of what you are taking this at this time. Okay. The last one we are going to go over is the orthocenter. These are the altitudes, okay? Altitudes meaning from each vertex, I'm going to drop a line perpendicular to the opposing side. These will intersect at a point. Usually we call it H, but it really doesn't, it's not important. H here is called the ortho. Ortho comes from the word orthogonal, or another word for perpendicular. Okay, orthogonal, so orthocenter. This is the center where all the orthogonal lines to the sides intersect. Okay, again, if we call that A, B, C, and then D, I said E, F, G. I don't know why I skipped the E, but anyways, D, E, F. It's interesting in that orthocenter to say that if I take any line and multiply H, remember there we divided HF by HA, and we said this is half of that, and this is half of that, and this is half of that. So, but here we say, if I multiply HE by BH, I get the same as if I multiply HC, or it doesn't matter which one you start with, but HC by DH or HD is the same as multiplying HF by HA or AH. Really, meaning these two lengths, instead of taking the ratio, like in the case of a median where we were finding the centroid and say the ratios are the same, and we just multiplied, say the ratio is 1 to 2, here we multiply them, and we say whether I multiply this by that, or this by that, or this by that, I get the same result. Interesting. Finally, we said if you have an equilateral triangle, then these all 4 centers will coincide. So we covered 4 of them. We said if we have, I think we did this first. Okay, we said the angle bisectors, that gives you the incenter. Why in? Because the circle is inside the triangle and touching each side at exactly 1 point. And then we said instead of angle bisectors, if we did the perpendicular bisectors, you get the circumcenter. This center is the center of a circle where the triangle vertices lie on its circumference. Hence the word circumcenter, from circumference. Okay, and then we said the median will give you the centroid, and the ratio of this piece to that piece, so from the point of intersection to the side or to the base, is half of from the point of intersection to the vertex of the same line. And finally, we said the orthocenter, that's where you have all 3 altitudes intersect at a point. The product of these 2 lines is the same as these 2, is the same as these 2 segments, not line segments, right? So that's basically it. I can give you a quick way to find the centroid. I don't think you will need that in this course, but for your own knowledge, it doesn't harm. Let me take a piece of paper here and say, I'm going to show you some stuff that you will use. I mean, I'm not going to go into half a circle and a quadrant and stuff like that, even though they are not hard, but I don't think you will need them. So what I'm going to do here is to say the following. I'm going to say degree, area, the x coordinate of the centroid, I'm going to call it x bar, and the y coordinate of the centroid, I'm going to call it y bar. And what is the degree? You should know that, oh, I should have also drawn the shape on the left. So on the left here, I'm going to draw the shape. And I say, here is my X and Y. X and Y. If I draw a rectangle, you see that the top line here is horizontal, meaning basically it's a degree 0 because the slope of this line is 0, right? It's horizontal, so it has a slope of 0. So I'm going to say the degree is 0. If I have a triangle, and notice I'm drawing the X and Y and the right angle, because that's, I told you it has to be a right triangle. The right angle is at the origin. Again, X and Y. That's a straight line. So your straight line equation, Y equals mx plus b, for example, you see the X is to the power of 1. So the degree here is 1. Here, if I ask you, what is the degree of X? You say there is no X. Y equals 4, for example, there is no X. So the degree is 0. If I have a second degree parabola, I'm not going to draw to scale, but I will show you something that will stay with you forever. You will never forget it. This is a second degree. I can do a third degree parabola. Third degree. So 3, 4, 5, 6. And so this line will get closer to the y-axis as you go down, to be smaller and slender. Okay, if I call this B and that's H for base and height. Okay, B, H, B, H, B, H. It's so easy. The area is BH. If I call the degree n, I will divide over n plus 1. So if the degree is 0, n plus 1 would be 1. B times h over 1 is BH. That's base times height. That's the area of a rectangle. For the triangle, it would be BH over 2. You know that, 1/2 base times height. For the second degree parabola, yes, you got it, BH over 3. Here it's BH over 4. If it's a 10th degree parabola, the area is BH over 11. You don't have to worry and look for and Google it. Nice? Wait a second. Where is the centroid in terms of B? The X, meaning I know that for the rectangle, it has to be in the middle, right? Because the right-hand side and the left-hand side would be the same weight or the same mass. So definitely it should be along this line. So it's B divided by n plus 2. N was 0, so this is B over 2. Here it's B over 3. Wait a second. Let's go back to the median. If this ratio is 1 to 2, meaning this is third of this line. But it works also if it's a right triangle. It's B over 3. That centroid is here. This distance is B over 3. That's X bar. Here it was B over 2. Here it would be B over 4. Here it would be B over 5, and so on and so forth. How about the Y bar? Meaning, how high is the centroid? Well, it's H over 2, of course. But the equation is slightly different. The equation says H plus 1 over 4H plus 2. N. Why did I say H? N, since we used N. So if N is 0, you get 1/2 for a rectangle, right? But if N is 1, you get 2 over 6. But 2 over 6 is simplified as H over 3. And this is H, of course, times H. Okay, so N plus 1 over 4N plus 2. If you have a second degree parabola, N would be 2, so the numerator is 3, and the denominator 4 times 2 is 8 plus 2 is 10, 3/10 of an H. And finally, for a third degree parabola, 3 plus 1 is 4, and 12 plus 2 is 14. 4 over 14 is 2 over 7 h. And these, you can remember them and get these centroids even in more advanced courses very quickly. You won't have to waste any time. Again, this was extra. It really has nothing to do with the centers of a triangle. But since we covered the median and we were talking about the centroid, I thought maybe I give you that extra piece of information. You can keep it for later. If you write these 0, 1, 2, 3, and you see here I add 1, I keep add 1 to the denominator and to find the area. I add 2 to the denominator to get the x bar, and then I do n plus 1 over 4n plus 2 to get the y bar. Okay, I hope you enjoyed that session. And again, if you have any questions, please let me know by dropping me a line in the note section. And I don't know why I keep saying the note session every single time. Anyway, thank you very much for watching, and I hope to see you soon. Bye.